Purpose of this video is for you to be able to describe what dissociation is and for account for why it occurs. We need to review a couple concepts. First off, what it means to be polar. Now, some bonds are covalent, but they're polar covalent, which means the electrons are being shared, but they're being shared unevenly. Now, since water is a polar molecule, it's going to have an uneven distribution of charge, and you're going to have a negative part and a positive part. The negative part is towards the molecule, towards the atom within the molecule that has the higher electronegativity. In this case, it's oxygen is the higher electronegative, more electronegative, and hydrogen is the less electronegative. Now, what that means is water is going to have this negative charge and this positive charge, and this is how it's represented. The chemistry uses this symbol delta. It's a lowercase d, the Greek letter. Delta means partial charge, and you can see the oxygen has negative charge and the hydrogen has positive charge. One other thing we quickly need to review is the way things look like as they're solid. Covalents are molecules where it's got this tiny version of itself that gets repeated over and over. Each one of these things is a molecule. Each one would be like a water molecule, and I've represented one thing with many other, one molecule with one ball, but this is kind of what it would look like. Now, ionic look a little different where they've got the checkerboard pattern. It's a little bit wrong there, the box moved, but ionic has that checkerboard pattern of cation, anion, or positive, negative, that repeats upon itself in 3 dimensions. All right, here, this slide's going to break up what ionic and covalent look like when they're in solution. Now, when they're not dissolved, they both look really similar. As you can see, they're in the bottom of the beaker. You could tell them apart from the water, like salt and sugar and water. But when they're dissolved, they look similar once again. And you can they spread out in the water. And now there would be more water molecules than just these two. It could be, many more depending on the size of the cation and so forth. I'll give you an analogy of what this is going to look like. Let's say we had these minifigures. The green piece is the water, and these things are the solutes. Now you wouldn't be able to see them per se in the water. They'd be kind of disappeared into the water. Now, the property of dissociation is something that only ionic compounds have or experience. This one, it's partially dissociated, and the reason it's partially dissociated is because half or some of these ionic pairs have separated into the water. As you can see, there's 4 pairs we start, and then 2 of them have separated. Fully dissociated would be where all 4 of them have separated into the cation anions, and they're all surrounded by water. Now, the reason this happens is because there's a positive attraction between the solute and the solvent. Let's consider the anion first. The anion is negative. Therefore, the positive ends of the solvent will surround it and sort of, hang out with it in the water. As you can see, the positive ends of these water molecules are on either side of the anion. In the cation, it's the same thing, except it's the opposite way, because cations are positive, therefore the negative part of the water or the negative part of the solvent will surround the ion. Dissolved, right? But they're not dissociated because these minifigures are in the water and they lose part of or separate from part of themselves their accessory, if it were. The accessory is like the cation, and the person is the anion. This is what dissociated would look like. Now that we know what these things look like, this should help us figure out which one's which. If I stick these in here, you can see that they light up on one, but not the other. That's because this solution has those ions that have dissociated, and it allows it to conduct. Salt, sugar, ionic, covalent. Just to recap, dissociation is when you put an ionic solution in solution, ionic compound like salt in solution, and the cation and the anion, they separate into two distinct things, and they float around being surrounded by water molecules. This process of separating is dissociation. Ionic compounds do it when they're in solution, sometimes, not all the time. Covalent don't.